Okay, so today what we're going to work on is review for the next test. So this is for test 2-3. So number 1 says to rewrite using radical notation. So remember that a fractional exponent is power over the root. Okay, so if I have xy to the 3/4 power, my power would be 3 and my root would be 4. So it would be the 4th root of xy to the 3rd power. And that would have to be in parentheses because it's the whole thing that's raised to the 3/4 power. And this could also be written as the 4th root of x to the 3rd, y to the 3rd. So they're both equivalent answers. If we have x to the negative 5/3, now remember, in order to do power over the root, you have to have a positive exponent. So to make this exponent positive, you put it into the denominator. So it's 1 over x to the positive 5/3 power. Now you could do power over the root. So it'd be 1 over the 3rd root of x to the 5th power. All right, let's take a look at C, which says to simplify and write with only positive exponents. So I have 5x to the negative 2, y to the 5th, over x to the 7th, y to the 8th. All right, so the first thing we're going to do is we're going to simplify the x's. I have the same base. When I divide same bases, we subtract the exponents. Nothing's going to happen to the 5. So this here would be negative 2 minus 7 would be x to the negative 9th. And then y to the 5th divided by y to the 8th would be y to the negative 3. Now I want to make these exponents here positive, so I have to take this and put it into the denominator, but not the 5. So it'll be 5 over x to the 9th, y to the 3rd. All right, let's take a look at D. D is in parentheses 2, x to the 3rd, y to the 9th, raised to the negative 1/3 power. All right, so I have power to a power. That means everything on the inside gets this power here. All right, so this has a power of 1. So it's 2 to the negative 1/3 power. Power to a power, you multiply the powers. X to the negative 1, y to the negative 3 power. So then I get, put this into the, everything's going to go into the denominator now. So it'll be 1 over 2 to the 1/3 power, x to the 1st power, and y to the 3rd power. All right, let's take a look at 2. Okay, so number 2 is to simplify. So the first one is a cube root, so you have to think of your perfect cubes. And the letter B is to, you want to simplify the algebraic expression. So this is the one where you factor and reduce. This one we're going to break it down. So let me write 2a. So 2a would be the 3rd root of 54, x to the 7th, y to the 3rd, z to the 8th. Okay, so we're going to break it down. I'm going to put all my perfect cubes on the left and my non-perfect cubes on the right. Perfect cubes on the left, non-perfect cubes on the right. All right, so what perfect cube goes into 54? That would be 27. So 27 times 2 is 54. 27 is a perfect cube. What perfect cube goes into x to the 7th? That's x to the 6th. Remember, the exponent has to be a multiple of 3. So x to the 6th times x is x to the 7th. Y to the 3rd is a perfect cube. And z to the 8th would be z to the 6th times z to the 2nd. All right, so now let's do our cube root. The cube root of 27 is 3. The cube root of x to the 6th is x to the 2nd. Right, you just take the exponent divided by the index, so 6 divided by 3. Y, the cube root of z to the 6th is z to the 2nd. And then I have the cube root of 2xz squared. All right, so let's take a look at 2b, which is the simplify and reduce. So it's 25 minus 4x squared over 2x squared minus 7x plus 5. All right, so I want to factor. Remember, you just can't start crossing things off like this. I'll make that a 5. This is a 1. This is 2. Can't do that. All right, so you have to factor and then reduce. Get it in a factored form. So 25 minus 4x squared is the difference of two perfect squares. So that becomes 5 plus 2x and 5 minus 2x over. Now I can factor the denominator. I have to do master product. So that's positive 10x squared. What multiplies to 10 adds to 7 would be 5x and 2x. Same signs, they're both negative. Bring down the 5, bring down the 2x squared. And then we'll group. So the GCF is x times 2x minus 5. And then the GCF is negative 1 times 2x minus 5. So my factors are x minus 1 and 2x minus 5. All right, so remember I have multiplication in between here and here. Start in the top left, work to the right. So I have 5 plus 2x, nothing in the denominator. And then I have 5 minus 2x. These two here reduce, they are opposites. So they reduce to negative 1. So then I'm left with a negative 5 plus 2x. Remember, put the negative right with the bar. Otherwise, if you're going to put in the numerator, put parentheses around the numerator. Over x minus 1. All right, let's take a look at 3. All right, so 3 is the transformations. All right, so 3a, I'm adding 5 to x. That means it's to the left 5. And I'm minusing 2 from y, so it's down 2. 3b, I'm minusing 10 from x, so that's to the right 10. And adding 4 to y, so that's up 4. C, I'm adding 3 to x, so that's to the left 3. And I'm adding 8 to y, so that's up 8. 3D, I'm minusing 4 from x, so that is to the right 4. And I'm minusing 1 from y, so that's down 1. All right, let's take a look at 4. All right, so 4 is to find the solution. You want to solve. So it's a system of equations. So I'm going to take my linear, which is this guy here, and I'm going to put it in y equals form. So I'm going to minus x. Y equals negative x minus 1. Now I'm going to set them equal to each other. So I'm basically doing a substitution. I'm substituting this in for y. So negative x minus 1 equals negative x squared minus 9x minus 16. I'm going to move the whole thing over to the left because I want my x squared to be positive. So I'm going to add x squared, add 9x, add 16. Add x squared, add 9x, add 16. Okay, so I get x squared, negative x plus 9x is 8x. Negative 1 plus 16 is 15, equals 0. All right, now I'm going to solve this. So you can use the quadratic formula. You can complete the square. You can factor. So I am going to complete the square. So I'm going to minus 15 from both sides. So I get x squared plus 8x equals negative 15. I'm going to do half of 8, which is 4, squared, 16 added to both sides. So I get x squared plus 8x plus 16 equals negative 15 plus 16, which is equal to 1. I'm going to factor. So I get x plus 4, which is x plus 4 squared. So I have x plus 4 squared is equal to 1. Square root both sides. So I get x plus 4 is equal to positive negative 1 minus 4. X equals negative 4 plus minus 1. So now I have to separate this. So I have x is equal to negative 4 plus 1, which is negative 3. And x is equal to negative 4 minus 1, which is negative 5. All right, so now after you get your x values, you need to get your y values. So I'm going to do that right here. When x is negative 3, I'm going to plug it into my linear, which was y equals negative x. That was negative x minus 1. So y equals... So my x is negative, and I want negative x, so that's going to be positive 3. minus 1, so y is equal to 2. And now I have to plug in negative 5 when x is equal to negative 5. So it'll be y equals 5 minus 1, so y is equal to 4. So then I put the word solution, and one solution would be negative 3, 2, and my other solution would be negative 5, 4. Okay, so let's take a look at number 5. So it's a piecewise function. So I have here f of x is equal to x squared minus 4 when x is less than or equal to negative 4, and f of x is equal to the absolute value of 4 minus 2x, where negative 4 is less than x is less than or equal to 4. And I'm looking for f of negative 1. So where does negative 1 fall? Negative 1 falls in this interval, so I have to use that function, that part of the function. So it would be the absolute value of 4 minus 2 times negative 1. So it's the absolute value of 4 plus 2. So it's the absolute value of 6, which is equal to 6. Okay, next one. I have f of negative 4. So f of negative 4, I have to use this one because it says x is less than or equal to negative 4. So it'll be negative 4 squared minus 4 times negative 4. Negative 4 squared is 16 plus 16, which is equal to 32. And then the last one is f of 2. So f of 2 falls in here in this interval. So I have to use the last one. So it would be the absolute value of 4 minus 2 times 2. So it's the absolute value of 4 minus 4, the absolute value of 0, which is equal to 0. Okay, let's take a look at 6. All right, number 6 says, looking at the graph below, determine the interval where the function is increasing and decreasing. Okay, so I need to find my max and my min. All right, so here's a min. So that's at 3, 0. And I need my max, which is at 1, 4. So underneath, you're going to draw a number line. And you're going to plot the x values of your max and your min. The x values. So this is a 1 and a 3. So now you're going to follow the graph. So as I read the graph from left to right, my graph is increasing here. So this, put all pluses in here. And then from here, from the max to the min, it's decreasing. So put minuses in there. And then from my min, it starts to increase again. So at the ends, put negative infinity, positive infinity. Okay, so it's increasing. It's increasing from negative infinity to 1 and from 3 to infinity. It's decreasing from 1 to 3. Okay, let's take a look at 7. 7 is the absolute value equation. So remember, absolute value, always make sure you isolate first. All right, so I noticed that with my absolute value, I have a 4, and that's a 4 times, so I divide everything by 4. So I get the absolute value of 2x minus 7 is equal to 9. Now I'm going to branch it off. All right, so for 1, it's going to be 2x minus 7 equals 9, and 2x minus 7 equals negative 9. So on the left, I'm going to add 7. I get 2x equals 16, and divide by 2, I get x is 8. And on the right side, add 7. Negative 9 plus 7 is negative 2. Divide by 2, I get negative 1. You have to check this. All right, so I'm going to start with negative 8. So it's 4 times 2 times 8 minus 7. Does that equal 36? So 2 times 8 is 16. 16 minus 7 is 9. So it's 4 times the absolute value of 9. The absolute value is 9 is 9. So it's 36 equals 36, and that checks. And now we're going to try negative 1. So it's 4 times 2 times negative 1 minus 7. 2 times negative 1 is negative 2. times minus 7 is negative 9. But the absolute value of negative 9 is 9. So 36 equals 36, and that checks. Okay, so also remember that on your test, so make sure you read this down here, you have to be able to do the word problems that involve the work. Okay, those are the ones that we had the packet on, and you have to be able to find the average rate of change. Okay, so please make sure you do know those two things. Okay, so that's it, and have a good night.
Mom.